Beneath the surface of things is a world where there is always questions to be answered. Physics is the study of that world, asking some of the most important questions about everything around us. Our need to understand has inspired some of the most profound discoveries, and your education in physics feeds the curiosity that drives us to unlock more about the world in every way.
What we do is we challenge people through physics so they can think about what they already think. For example, what do you imagine is going to happen if I drop something? Or what do you think happens if there is a collision between a bus and a car?
Physics is kind of the art of solving problems. And when you take physics, really what you're trying to learn to do is how to think critically.
Physics gives you tools and understanding to really grasp the universe on a deep and fundamental level in ways that other disciplines don't.
Well, physics is probably the most fundamental of all the sciences. It's an attempt to simplify the world around us and create models to predict how nature behaves.
In many other areas of thought, I find that the questions are never truly answered, that there is always a different interpretation, that there is always a different way of looking at things. And that's not the case in physics. Physics is rigorous, it's tested, and it's a chance to actually come to a consensus that, yes, this is how something works.
A lot of times you'll look at an article or something on the internet and part of your brain is always screaming, show me the data in the back of your head.
It's a discipline where you work very hard to get an answer to something, and when you finally get it, you say, oh my God, now I see it.
Careers in the sciences continue to grow each and every year. Pursuing a career in physics can be very rewarding as a jumping-off point to so many other areas and professions. As a focus in your science education, physics has an advantage as it revolves around the laws and processes that affect areas like manufacturing, medicine, energy, and so much more. Which is why physics doesn't have its own industry. Rather, it's a discipline found in nearly every industry.
So I was offered a position here at Goddard to help develop a polarimeter to look at black holes and look at the polarization of X-rays coming from black holes. And so I moved from working on SWIFT to developing a new technology. So for SWIFT, the prime thing was looking for these gamma ray bursts and waiting for a gamma ray burst, which can happen at any time, go off in the universe, and then one of the instruments, not my instrument, but the gamma ray burst instrument, detects one of these huge explosions halfway across the universe and tells the spacecraft to go move and look at it.
I represent the interests of our more than 50,000 members with regard to science policy issues. I work with Congress as well as the White House on issues related to science policy and issues that are of concern to our membership.
What we learned from the research that I'm doing is how does energy get transferred from the solar wind throughout the near space environment and how it's ultimately deposited in the atmosphere. And this is interesting for Earth because it helps us figure out how the atmosphere evolves over the lifetime of the Earth. How do we set up atmospheric escape processes?
I work in areas of STEM education, in federal budgets for science agencies, and I also work with the community doing grassroots organizing and advocacy.
I'm working on a project where we're trying to detect gamma ray bursts, but we're trying to do it in a kind of a new, inexpensive way. And so we're working on an idea right now to actually build a system of small satellites which can orbit the Earth and detect GRBs and gamma rays.
I focus on the nanoscale, and the reason we look at things in such a small, detailed scale is that we can get new phenomena out of the material and new properties out of the material when we scale it down. I work on hydrogen storage materials, and with these materials, once we heat them up, we want the hydrogen as a gas so that we can use that as a fuel in fuel cells to generate electricity.
The kind of research that I do is I'm a member of one of the instrument teams on board the Cassini spacecraft. So Cassini is a flagship mission that orbits this, it's in the Saturn system, so it orbits Saturn. Tons of different gases in the atmosphere that emit, and also the particulates, the aerosol, and the ices emit as well. And that's what I pick up on, and I model to try to understand their behaviors and their characteristics.
People who study physics and astrophysicists don't always come to work at NASA. A lot of times they'll go work in academia, they'll work as research scientists at universities or as professors.
He was able to apply what he had learned as an astrophysicist to actually working for Fannie Mae, and they have him looking through huge quantities of data, looking for trends and things.
Labs that use large particle accelerators, trying to find out what the universe was like at its very earliest moments. I think these are some of the most exciting things. What is the future fuel going to be, for us? Nuclear fusion, for instance, is certainly one of those possibilities.
The structures inside of these chips, these devices, are getting on the sort of the size level where quantum mechanics is a very significant issue. And so they need really highly trained theorists to understand that, to be able to design these new devices.
It doesn't much matter whether this is an issue of I'm a professional physicist or I have a background in physics. People who study physics tend to have a much better economic security than people who go into many other fields.
They work in Wall Street, they work in the computer industry, they work in the health industry, and they're all physicists.
In the next 10 years, the job growth in the fields that demand STEM skills will be double that of job growth in other fields. Large data set analysis, quantitative thinking. There is a huge demand for people with the skills that physics instills.